I will now show you how to use the memory address of a variable in order to go to that specific location in memory and read out the value that's stored there, as well as change that value if you wanted to. I'm starting out with a program that's very similar to what we just studied. We have declared a variable I and initialized it with the value 42, and then another variable I address that is there to store the address of an integer. Furthermore, I'm initializing I address with the address of I. We could have done these two things in one line. Alternatively, we could have simply said int star I address equals address of I. But I chose these two lines because I want you to see both ways of doing this. And finally, we print out the address of I with a %p format specifier and I itself. So this we have done before. Let's quickly compile this, and I'm just going to run the whole program. The address of I is fffc and I equals 42. All right. Now I want to show you how to replace this I back here, whose value we're printing with a %d format specifier, by using only the address of I. So I want to use the address of I here in order to reach what's stored inside I. I can't write it just like this because this prints out the address itself. I don't want to print out the address. I want to reach what's stored at that address. In order to do so, I need to what's called dereference this pointer, this memory address. Dereferencing a pointer or a memory address means to go to the actual variable and read out what's stored inside it at that memory location. And to do so, I simply put a star in front of I address. This star indicates I'm not interested in the address itself. I'm interested in what's stored at that address. And that's actually the value that's in I. So if I compile this and run this again, this time step by step, you'll see it works. First, I is initialized with a value 42. I address is declared and initialized with the address of I, which is fffc, as you can see in the memory representation. And then our printf statement prints the address of I is fffc and I equals 42. So despite the fact that I don't have I here, rather I have the dereferenced pointer I address, I'm able to print out the value that's stored at that address, which is the value of I. So let's go a little bit further and declare a few more variables. How about we also declare a double? And we'll call it 3.14. And then we need a pointer or the address of a double, so double star. I'll call it A address, and we'll initialize it right here as the address of A. And why don't we also use a character, C, and as always, we initialize it with the value P, and then we need a character pointer. I'll call it C address. That's going to hold the address of C. All right, and now we also want to print similar information for A and C. I'm going to copy and paste this line so I don't have to type it 3 times. So the address of A, my double, is going to be printed here, and A itself. So I need the address of A and the dereferenced address of A. The dereferenced address of A goes to the memory location specified by A address and reads out what's stored inside that memory location. In order to interpret that correctly, the computer needed to know that A address is a pointer to a double, so that what's stored at that memory location represents a double, rather than I address, which stores an integer. So by dereferencing, we go to the memory location and then interpret what's stored there. It's a bunch of zeros and ones. It's all stored in binary. Interpret that as a double or an integer or a character. So in the third line here, we're reading the address of C. And so we need the address of C and then the dereferenced address of C, which will print that out as a character. And here we should print this as a float. All right, let's run this again. And let's run this step by step. First, I is declared and initialized as 42. Then comes the address of I. We haven't initialized that yet, so for now it doesn't carry a really useful address. Then comes A, which holds the value 3.14 as a float. And then comes the address of A, which is FFF0. And we declared it and initialized it all in one step. Then comes C, which is a P, and its address, which is FFEB, as you can see in the memory representation. And finally, we're changing the value that's stored in I address to the actual address of I. So watch what happens to the variable I address. Now it has the address of I stored in it. Next, we get to all of our printf statements. First, I'm printing out I's address as well as the value of I itself, but I'm not printing I, I'm printing the dereferenced pointer I address, which is the same as printing out I, as we know. Next, I'm printing out the address of A and the dereferenced pointer A. I'm printing that out with the format specifier LF, and so I'm printing out the value of A, 3.14. And finally, I'm printing out the address of C and the dereferenced pointer C address, which simply accesses what's stored at the location where C sits, which is my P. All right, so that's pretty cool. We can access what's stored at a certain memory location simply by dereferencing that pointer. And since the pointer has a type to which it is pointing, the computer can interpret what's stored at that address properly, either as a character or as a double or as an integer and whatnot. There's more to this. We can also change what is stored at a certain memory location. For example, I currently has the value 42, and with $I address, by dereferencing the I address pointer, we can access what's at that location. Well, we can then also change what's stored at that location by simply typing I address with a star in front of it on the left-hand side of an assignment statement and the value that we want to change it to on the right-hand side. This changes the value that's stored at that memory location to a 50. Let's check it out. I'm going to print out the same line as before of I is %P and I equals %D, but this time I'm going to print the address of I, which hasn't changed, but I'm also just going to print I itself to show you we can access I in either way, either by using I or the dereferenced pointer I address. So let's run this. I'm going to go step by step. The first steps I'm going to go through rather quickly, all of our initializations. Here come all the print statements. And now I'm about to get to this statement, $I address equals 50. So watch what happens to I as I hit the next step. I changed its value to 50 because $I address is the memory location of I dereferenced. And that's exactly what's stored at I. I'm changing what's stored at I to 50. When I print this out now, it says the address of I is FFFC, just as before, and I equals 50. So the memory location hasn't changed. The variable is still stored at the same location, but the value of the variable has changed. I can now do the same thing for A and for C. And in order to do so, I'm going to copy these two lines and paste them in there so I don't have to retype everything. So let's say we want to change the variable A. So we need to dereference the A address pointer. And A is a double, so let's put in 2.1718, for example. And then we're going to print out the address of A and what A equals. So we need to use a format specifier of LF. Use the address of A, and we're going to print A back here. And then the same thing for C. So we want to change what's stored at the address of C, which is C. And why don't we give it a value of B instead? And then the address of C is %P, and C equals, we need to print that out with a %C format specifier, C address, and C. And this time, let's compile again. And again, we're going to go through the first steps rather quickly until we get to this point where I changes. So we're dereferencing the address of I again. Watch what happens to I. I changes its value to 50 when we dereference the address of I and put a 50 in there. We print that out. Now watch A. Currently, there's a value of 3.14 stored in there. By dereferencing the address of A and assigning that location a new value, We're changing what's stored at A. Then we're printing that out. And finally, watch what happens at C. Currently, there's a P stored in there, but by dereferencing the address and putting a B in there, we're changing what's stored at C, and we can print that out similarly. So this is how we dereference a pointer or an address. It's a very important concept, and you can already feel that this will help us change values of variables inside functions. So if you pass an address of a variable to a function, that function will have access to A, what's stored at that memory location, and B, be able to change what's stored at that memory location. So this will give us another way to pass variables to functions in order to change what's stored in those variables.